we're going to do two problems with horizontal stretches or compressions, looking at that horizontal transformation. This first one, you have to start by factoring the 4 out of the expression. So it stays inside with the x, but it has to factor away from the x. So that'll be 4 times x and 4 times 1 to get the original problem. That whole quantity is still being squared, which tells me it's a quadratic equation, a parabola. So when I'm thinking of transformations, I need everything that's being squared, because those are going to create horizontal or x transformations, and then everything outside is your vertical. When you look at this then, naming those transformations, the negative gives us a reflection over the x. This 4 we know is actually 1/4, which makes it be a horizontal compression. We go left 1 and down 4, right? Based on that, we know that our vertex, this is vertex form, so our vertex is actually that -1, -4. Helps when you write what you say. -1, -4. And since it's a reflection, that tells me it turns down, opens down, and that makes it have a maximum. The axis of symmetry is based from the vertex, so that's going to be x equals -1. Axis of symmetry has to be an equation. Parabolas, quadratics give you parabolas. Parabolas always have a domain of all real. And you can write that as -infinity to +infinity, or the interesting r character. Our range, since it opens down, it's going to start at -infinity and work its way up to the vertex, which will have a -4. And it has a point there, so it's a bracket. Infinity always gets parentheses. To put this on the graph then, we're going to start with our vertex, -1, -4. We know it's going to open down, and when we do that, our transformations will tell us to reflect, so go down. And the horizontal compression says instead of going over 1, down 1, you'll only go over 1/4 of the way to go down 1. So on both sides, you'll go 1/4 of the way to go down 1. In order of going over, in order to go 2, 4, we only go 1/4 of 2, which is a half, but we still go 1, 2, 3, 4 down. And half of the way down 4. This is going to be one very skinny little parabola, right? So the next question at the bottom of your page, you're asked to describe in words what a horizontal compression looks like. And a horizontal compression is actually going to push those sides of the parabola in, compress it on the left and right side. So it is going to make the shape is going to be much skinnier, if you will. It's going to look something like that, or like that. It's going to push those sides in. Hopefully you recognize that that's similar to another transformation we know, a vertical compression. There's a relationship there. Next one, we've got that half that we're going to factor out, and I hope you're getting more comfortable with factoring those fractions. We'll factor the 1/2, leaving us an x plus, and it's not half of 3, it's half of what gives you 3. So that's a 6. These are still inside the parentheses. We're just moving it away from the x, so that's squared plus 3. This is an equation. Don't forget to keep writing your y equals or f of x equals. Naming the transformations then, that is, since it's with the x, it's going to be a 2, not a 1/2. You use the reciprocal. Again, it's with the x, so it's horizontal. And a 2, if you double something, you're going to make it stretch. Then we'll go left 6 and up 3. Vertex then, based on these or these, will be a -6 and a +3. This one does not reflect, no reflection over the x, so therefore it is a minimum, meaning it opens up. Right? Axis of symmetry is always based on your x value of the vertex, and it's x equals, it's an equation, x equals -6. Domain, like we said, always all real, and the range, since it's opening up, it starts at the vertex and goes to infinity. Y value of the vertex becomes range, deals with y's. To get the graph on this one, we're going to go to our vertex of 6, 3, and then we're going to, our transformation says instead of 1, 1, we stretch it. We go 2, 1, both sides, and instead of 2, 4, we go 4, 4. That one's going to fall off of your graph a little bit. Rarely can we make these fit entirely. So look something like that. All right. Hopefully horizontal stretches and compressions are starting to make sense. This one was a horizontal stretch, and below on that page it asks you to describe in words what a horizontal stretch looks like to the shape of the graph, what it does to the shape of the graph. And it's going to make that parabola open up. It's going to make it wider, more open, if you will, up or down, whichever direction. It's going to make it something like that, or more like that, opening it up. Hopefully you recognize that there's a vertical transformation. A vertical compression is similar to that. Okay, looking at 6. On 6, we're going to be asked to complete the square. And we're actually going to forego all of the graphing because nothing's going to change there. We're just going to complete the square. Remember to complete the square. Complete the square. You're only looking at the x values when you factor. That is the one thing that changes. So we pull the 2 to the front. That's going to be x squared plus 1x. We put our blank in there. We bring whatever number there was, whatever constant, to the outside. We subtract our blank, and if the original blank is multiplying, this one has to too. So we're going to get y equals all of that. You fill in the blank by simply taking half of the middle, squaring it. Well, my middle is 1. Take half of that, so that's a half. Squared. 1 squared is 1, and 2 squared is 4. So both blanks become a 4. The 2 would be on the outside. That's going to be an x plus. Either take half of the middle, which is a half, or take the square root of that, also a half. Or you can do the x plus 1/2 and x plus 1/2 type of factoring first, and then get the squared if you need to. Out here we're going to have -1 and 1/4 of 2. Remember that's over 1, so that's 2/4 or 1/2. So that's a -3 halves, 1.5. Right? Depending on what you need to do with it. If I'm graphing it, I know I have a vertex at a -1/2, -1.5, or -3 halves. And I know it's a vertical stretch of 2. Right? Your graph, if you want to go ahead and try that one, would look something like that. And a vertical stretch of 2 would tell me to go over 1 and up 2. So I would look something like that. I know I said we wouldn't do it, but just in case you want to try it on your own. And 2 should go 4, but it'll actually go 8. So it would look something like this. All right, so moving on, we're going to do number 8 as well. 8, they ask us to complete the square, and when we do that, we're not going to involve the 19. We're simply going to factor both the negative and the 4 away from those, so that becomes x squared. Don't forget about your sign. That becomes a -5x plus blank. Keep your -19, minus blank, and our blank has to multiply by -4. If you follow that same format every time, you're going to be fine completing the square. It is going to get ugly with this one because we have to take half of 5. Well, that's 5 over 2, 2.5 squared. You will be better off if you work with fractions. So 5 squared gives us 25, 2 squared gives you a 4. All right, so that'll be 25/4. We'll come back and work with that in a moment. Factor over here, so -4, that's x minus half of the middle or the square root. It's the same number that you squared just a minute ago. 5 halves squared. For this part, that is a -19. Remember, this is 4 over 1, so that gives you positive 100 over 4, which is 25. Or if you noticed, your 4's could cross cancel. Whichever way, however you want to work with those fractions. So that should give you a +6 on the outside. Again, we're not really going to worry about focusing on details, but if you wanted a quick graph just to think about that, that would go right 2.5 and up 6. And it has a vertical stretch of 4 down. So it's going to look something along those lines. I'm not going to count that next one because 4 times 4's going to be way off my graph. But it'll look something like that. All right. Last thing we need to talk about is next week we are going to have you choose the best method. So you're either going to be given standard form or vertex form. We won't start you with intercept form, I don't think. If we do, find your intercepts. But if you've got standard form, there's 2 different ways you could approach it. Hopefully what you could do is you could just straight up factor it. If you can factor all 3 terms, whether that be trial and error or GCF of all 3, then go for that and set those equal to 0 and get x-intercepts and continue just like we have. Once you know your x-intercepts, you find your midpoint to get the vertex, plug the x value of the vertex in to get the y value, and basically you're done at that point. Find your y-intercept if you need an extra point. If it won't factor though, if it won't do trial and error, or all 3 parts don't have anything in common, then you're going to want to complete the square. And I'm just going to tell you, for an example of complete the square, look back at 6 and 8 that we just did. Those were a little harder than what you'll probably encounter most of the time, but the process is still the same. Factor the x squared and the x, and then if you need to, if the x squared doesn't have a coefficient besides 1, then you don't even have to factor. Plug in your blank, your plus blank with the x's, move the constant to the side, and minus that blank. All right? If you, and that process, completing the square, puts it in vertex form. So if you complete the square to get to vertex form, then you're just going to do this. And if they give you vertex form, you just want to name your transformations. And then all you have to do is name your vertex, graph your vertex, and then simply move the 1, 1 point based on the transformations, and move the 2, 4 point based on the transformations. So reflect it or stretch it, whatever way you need to do. Thanks.